So let's now consider the displacement, velocity, and acceleration versus time graphs for a body undergoing simple harmonic motion. Okay, so we said that the position was given by x is equal to a cos omega t plus phi. So this point here is going to be when t is equal to 0. So this has magnitude a cos phi. Our equation for the velocity is equal to minus a omega sine omega t plus phi. And our expression for the acceleration is minus a omega squared cos omega t plus phi, which is equal to minus omega squared x. So you can see immediately the relationship between x and a. We've got a negative sign here, so any number which is positive up here will be negative down here. When we're 0 up here, will be 0 down here. So that's the relationship between those two. Between these two, we're going from a cos function to a sine function. There's also this omega, which is going to change the amplitude of our function. But as you can see, when cos is at its maximum, we know that sine is 0. When cos is 0, sine is plus or minus 1. So this will have its maximum and minimum values when the cos function, the displacement function, is at 0. You need to know the relationship between these curves. Okay, so omega, we said that it satisfied the equation minus k on m is equal to x is equal to minus omega squared x. So we've already shown that omega is root k on m. Now what we want to do is work out the relationship between omega and the period of the motion. Well, the time between two maximums is one period. When we travel from one maximum point to another maximum point, it takes a time t. The maximum positions occur when cos omega t plus phi is equal to 1. So the first maximum we can say is when omega t plus phi is equal to 0, because that satisfies this equation here. Now the following maximum will occur 2 pi radians later. So it will occur when little t has passed plus big T plus 1 period. So our time is replaced with little t plus big T plus phi, and this is 2 pi radians later, so it equals pi, 2 pi. So now we just need to solve these simultaneously. So we've got omega t plus phi is equal to 0, and omega t plus big T plus phi is equal to 2 pi. Let's call this one 1, this one 2. Let's go 2 minus 1. The omega t's cancel out and we end up with omega capital T. The phi's cancel each other out and we end up with 2 pi. So we can see that t is equal to 2 pi over omega. So that's our relationship between the period and omega, or omega is equal to 2 pi over t. Now, as you know, the period is the inverse of the frequency. So we could also write omega is equal to 2 pi f. Okay, now we can also write this, because we've now got our omega is equal to 2 pi f, but we've said omega is equal to root k on m. So if the omega is on the bottom, we've got t is equal to 2 pi root m on k, and f is equal to 1 over 2 pi root k on m. Actually appears on your formula sheet. Now, to practice using it, you should practice homework set 5. For Phys 1121, try questions 7 and 9. For 1131, have a go at 8, 10, 11 and 15. Now we've got a little activity for you to try. I've placed a 500 gram mass on this yellow spring here. In a minute, I'm going to time 30 seconds, and I want you to count how many times the spring oscillates in that 30-second period. One oscillation is when it goes from its highest position to its lowest position and back to its highest position. Okay, so let's start it going. Okay, get ready, steady, go. stop. Okay, so that was 30 seconds. Hopefully you got how many times it oscillated. Now what I'm going to do is replace this 500 gram mass with a 1 kilogram mass. Now, before I start this springing, I want you to make a prediction about how many times this 1 kilogram mass is going to oscillate in a 30-second period. Okay, enter that in now.